everyone, this is the first video in a series of videos centered around basic statistics for data analysis. Today, we're talking about descriptive statistics. Descriptive statistics are the methods that we use to organize and summarize data. You can kind of think of it as a first look into your data set. It helps you make sense of patterns, trends, and overall structure that you see in your data set. Descriptive statistics includes two things. 1, measures of central tendency, and 2, measures of variability. First, let's start with measures of central tendency. Central tendency tells us where the middle of our data is, and there's 3 different measures for this: the mean, median, and mode. The mean is the average of the data set, and it's taken by taking the sum of all the values in the data set and dividing by the number of values in the data set. The median is the middle value of the data set, and we find this by ordering the values from smallest to biggest and then finding which one is in the middle. And finally, the mode of the data set is the value that is most frequently occurring in the data set. Now, you may be wondering when to use each of these measures of central tendency. Well, the mean is best suited to describe a data set where there aren't a lot of outliers. This is because outliers in a data set can greatly affect the average of the data set. For example, if you have a very high outlier, this will take the average of the data set up and kind of misrepresent where the middle of the data set is. If you have a data set that has a lot of outliers, the median is the better measure of central tendency to use. That's because this measure is less affected by outliers. Finally, the mode is best to use to describe a data set when you have a lot of categorical variables. Now let's look at an example. Here we have a sample of a data set that contains housing prices. This is just a sample of 10 rows from a Kaggle dataset. I'll link the dataset down below if you're interested. So first, let's see if we can find the average or the mean of this dataset. We have the 10 values, so we add up the 10 price values and divide by 10, and we get that the average is about 4.5 million. We can get the median by ordering the price values from smallest to largest, and then we look at the middle value, which in this case is about 4.4 million, and we can find the mode of the prices as well, which is the most frequently occurring value, which in this case is $3.5 million. So overall, it looks like this data set contains some pretty high-end, expensive houses. Now that we've got central tendency and its measures down, let's move on to variability. Variability is the measure of how spread out our data set is, and there's 4 ways to measure this: range, standard deviation, variance, and interquartile range. The first measure is range, and it's just the difference between the smallest and the largest value in a data set. This isn't a very robust measure because it's greatly affected by outliers. If you all of a sudden have one data point that is very high or very low in your data set, the range will drastically change. The second measure is the standard deviation, and the standard deviation tells you, on average, how far each value in your data set is from the mean of the data set. This is generally used when you have a normal distribution, which is something we'll get to in a minute, but generally it's used when you don't have too many outliers in your data set. The third measure of variability is variance, which is just the standard deviation squared. This is generally used in statistical tests like ANOVA and is generally used with normal distributions as well. And finally, the fourth measure of variability is interquartile range, which gives the spread of the middle of your data distribution. To really understand interquartile range, we first have to understand what quartiles are. Quartiles are 3 points in a data set that divide the data set into 4 parts. These 3 quartiles are known as quartile 1, quartile 2, and quartile 3. Pretty aptly named, right? But quartile 1 is the point in the data set where 25% of the values in the data set lie below the quartile 1 value. Quartile 2 is the midpoint of the data set. It's also the median of the data set, and that's where 50% of the values in the data set lie below the quartile 2 value. And then quartile 3 is the value where 75% of the values in the data set lie below the quartile 3 value. So the interquartile range is just the difference between quartile 3 and quartile 1. And that gives you the range of data in the middle of your data set. Because the interquartile range focuses on the middle 50% of the data, it's less affected by outliers. So this measure of variability can be used for skewed data sets, which are data sets that have a lot of outliers, and for normally distributed data sets as well. Knowing the variability of the data set is important because we want to know if we have low or high variability. Low variability is ideal because it means the values in our data set are more consistent. If we have high variability, it means that the values are more spread out and less consistent. For a data set with high variability, it is harder to predict values in that data set. So back to our housing data set example. Here we can see that the range is $4.2 million. The standard deviation is about $1.4 million. This means that on average, the price of each house in this data set is about $1.4 million away from the mean price, which remember was about $4.5 million. The variance is this very large number. This number is so big because it is the standard deviation squared. So it's 1.4 million squared. Generally, the standard deviation is the more interpretable value between standard deviation and variance because the standard deviation is reported in the same units as the original data. So in this case, the standard deviation is listed in dollars, whereas the variance is in dollars squared. So standard deviation is more interpretable. And finally, the interquartile range here is to about $2.1 million. Finally, let's review distributions. Distributions are the shape of your data. In a normal distribution, most of your data is centered around the mean and it tapers off at the end symmetrically. If you've heard of the term bell curve or seen a distribution, most likely it was a normal distribution, which looks like this. In a normal distribution, about 68% of the data falls within one standard deviation of the mean. And it's important to note that to utilize most statistical tests, you have to make sure that your data is normally distributed first. The other type of distribution is a skewed distribution, where the data is not symmetrical. And there's two types of skewed distribution: left skewed distributions and right skewed distributions. These are also known as negatively skewed distributions and positively skewed distributions. In a right skewed data set, you'll see a tail to the right of the middle of the data set. And this means that there's a lot of high values in the data set, a lot of outliers on the higher end of the data set. On a left skewed data set, you'll see a tail to the left of the middle of the data, which means there's a lot of lower values, a lot of lower outliers in the data set. It's also worth noting that in a right skewed data set, the mean is greater than the median, and in a left skewed data set, the mean is less than the median. Recognizing what type of distribution you have is very important in your data analysis because it helps you understand which statistical tests can be applied to your data set as is, and if any transformations are needed to your data set before applying statistical tests. Alright, so that is a wrap on descriptive statistics. As a review, descriptive statistics is a first look into your data set, which helps you identify patterns, trends, and the overall structure of your data set. And there's two main things included in this: central tendency and variability. Central tendency includes mean, median, and mode, and the measures of variability include range, standard deviation, variance, and interquartile range. We also talked about the different types of distributions and how to identify a normal distribution versus a skewed distribution. In the next video in this series, we will talk about inferential statistics. I hope to see you there. Thank you so much for watching this video, and I hope to see you in the next one. Bye!